All right, guys, today we're going to review and go over adding and subtracting fractions. So a couple important things. The biggest one that you see right there is you have to have a common denominator. And the reason why that is think about a pizza. If you had things that were cut into different slices, we couldn't necessarily put them together and see the exact amount. So we'd have to cut them into equal slices, tenths or sixths or fourths or whatever, to see how many put together would make a whole or anything like that. So we have to have a common denominator. So these boxes right here are going to help guide us for having a common denominator. So when you look at it, we're going to put those whole numbers with these mixed numbers. So you have a whole number and a fraction. We're going to put those whole numbers on hold. We don't have to change those. So when you think about your multiples of 10 and your multiples of 6, they're going to meet at a lot of places, but we only want to know where the 10 and the 6 are going to meet. Those are your common denominators, because remember it's numerator and denominator. So what I like to do is think of your bigger number, which actually, if it's 10 is your bigger number than 6, that means that your tenths are going to be smaller pieces. What you would think of is, think of your multiples of 10, 10, 20, 30, 40, 50, 60, 70, 80, 90, 100, and so on. And then your multiples of 6, 6, 12, 18, 24, and so on. Where are they going to meet first? So 10, if you look at it, 6 can't never go into 10, so that's not going to be my common multiple. Sometimes that works. But here are my steps right here as I'm talking about it. We're going to choose a denominator and make new equivalent fractions. We're only going to add or subtract the numerators. That denominator is going to stay the same. Then we're going to add or subtract the whole numbers, and then we're going to simplify or reduce your fraction, and make sure that also means changing your improper fractions to a mixed number. So we'll review a couple of those too. All right, so let's go back to this. 2 groups of 10 is 20. 6 can't go into 20. 10 times 3 is 30. Ooh, that works because 6 times 5 is 30. Now, a lot of people just want to multiply these and say, oh, 10 times 6 is 60. And you're right, 60 is a common denominator, but if we get their least common multiple, their least common number, the number that they have in common, it actually helps us reduce less at the end. So just kind of something to think about. If you did 60, you wouldn't be wrong. So now we need to do our scale factor. 10 times 3 got me to 30. So what I do to the denominator, I have to do to the numerator. So 3 times 3 is 9. 6 times 5, 5 groups of 6 got me to 30. So what I do to this denominator, I do the same to its numerator. Okay, so that's why I would say cover these up and go step by step. So 1 times 5 is 5. So we have our common denominator. We made equivalent fractions because 9/30 reduced to 3/10 and 5/30 reduces to 1/6. We're only going to add or subtract the numerators. So 9 plus 5, 10, 11, 12, 13, 14. And then it says my denominators are going to stay the same. Okay. Now we add or subtract the whole numbers. 11 plus 7 is 18. So 18 and 14/30 is the sum of 11 and 3/10 plus 7 and 1/6. But lastly, we're going to simplify your answer. Okay? So we have to think about what that means. Simplify means reduce. So 14 and 30 can both be divided by 2. So that would give me 14 divided by 2 is 7. 30 divided by 2 is actually going to be 15. And then you're just going to bring your whole number over. It stays the same. So 18 and 7/15. Ask yourself, can I reduce once more? Well, 7 and 15 don't have anything in common other than 1. So you know that you're reduced all the way. So your final answer is 18 and 7/15. Let's try a few more, and then you're going to have some on your own. All right, this next one is 5 1/2 plus 3 1/3. Again, we're only looking at our denominators, so 2 and 3. If you list your multiples of 2 and you list your multiples of 3, you want where they're going to meet up first. They're going to meet up at 90. They're going to meet up at 30. They're going to meet up at several places, but we want where they meet first. So I always look at the bigger number and do its multiples to see when that smaller number would go. So 2 can't go to 3, so that's not my common denominator. 3 times 2 is 6. Can 2 get to 6? And hopefully you said yes. So that's going to be my common denominator. So 3 times 2. So what I do to the denominator, I'm going to do to the numerator right there. 1 times 2 is 2. 2 times 3 is 6. So that's my scale factor, and I'm multiplying up there. 1 times 3 is 3. So I chose my common denominator, and this one was 6. I made equivalent fractions. Now I'm going to add or subtract the numerators. So 3 plus 2 gives me 5. I'm going to keep my denominator the same, so it's 5, 6. And then add or subtract my whole numbers, just depending on the operation they give me. 5 plus 3 is 8. Simplify if needed. Well, 5 and 6 cannot be divided by anything else other than 1. So that was nice. It's already simplified for us. All right, let's practice a subtraction problem. 5 6 minus 3 fourths. I can't take fourths away if they're cut into 6. That's the whole point of this. We can't add things that are not like each other. But we can add 6 to other 6. So that's what we want you guys to think about. That's why we have to have that common denominator. That's why that's our first step. All right, so we've got 6 compared to 4. So again, listing your multiples of 6 and listing your multiples of 4, where are they going to meet first? So start with your number 6. Can 4 ever get to 6? Well, 4 times 1 is 4. 4 times 2 is 8. So nope, that can't go. So 6 times 2 is 12. Can 4 get to 12? Sure can. So we're going to have to put 12 right there. A lot, again, people want to put 24 there, which you're not wrong, but then you're just going to have to do some more reducing. So if you could get to their smallest common multiple, it'll make your life a little bit easier when you have to reduce. So let's go ahead and see, how did I get from 6 to 12? I did 6 times 2. So there's my scale factor, a number that I multiply. 5 times 2 is 10. So 10 twelfths is the same value as 5 6 because it reduces back to 5 6. Then how did I get from 4 to 12? I did times 3. So 3 groups of 3 is 9. So we have our common denominator is 12. We made our equivalent fractions. So now we go to this next part. We add or subtract the numerators. So 10 plus 9, or excuse me, we're subtracting on this one. I'm glad I caught that. 10 minus 9 is 1. And my denominator stays the same. If you had 10 twelfths and you took away 9 twelfths, you only have 1 12th remaining. This one doesn't have any whole numbers, so good news, we are finished on that one. You're going to try this one on your own in just a minute. So let's look at this last little guy thinking right here. Can you change one denominator to match the other? Meaning, do you have to change both numbers, or could you only have to change one? So that's what we were talking about up here. Could we get these smaller numbers to those bigger numbers? So let's look. 4 and 12. So 12 is my bigger number. So if you stop and think, is 12 a multiple of 4? Can I get from 4 to 12? And hopefully you said yes, because we can say times 3. So good news, you don't have to change this one. You only have to change one of them. And that makes your life a little bit easier, only having to change one of them. So 3 times 3 is 9. Let me use my blue color. That was my numerators. So now that I do that, we can go ahead and say 9 twelfths plus 1 12th. So we're adding, subtracting just the numerators. So 9 plus 1 is 10. We keep the denominator the same. And then we add or subtract the whole numbers. So 2 plus 8 is 10. So again, I'm just following these steps. And then we're going to simplify. So I have to think to myself, can 10 and 12 both be divided by the same number? And hopefully you said by 2. 10 divided by 2 is 5. 12 divided by 2 is 6. And then don't forget that whole number. Just put that in front of the mixed number. You're only reducing the fraction in the mixed number. So that would be your final answer of 10 and 5 6. So you're going to try these two problems on your own. And don't forget to reach out to your teacher if you do need help.